Hello, in this video I'm going to go over an OCR 2020 question, A-level vectors question. It was fairly early on in the paper, but despite that, the second part caused some problems, apparently, reading the examiner's report. I think, generally speaking, vectors problems, some students are fine with them, but a lot of students find them a bit threatening because I think basically they're all a bit different and they're all a bit problem solving. Geometry, geometric reasoning, and there's not really that much to know beyond even things at GCSE. Yes, you've got this new stuff with I, J and K, but that's not really much to really understand, unit vectors in a particular direction and thinking of three-dimensional coordinates. So you kind of got X, Y, and Z here as coordinates, and then I, J and K are just unit vectors in those directions. I is a unit vector with unit magnitude 1, J that direction, and K this direction. So, and then finding the magnitude of a vector is like 3D Pythagoras, but a lot of this stuff in principle is covered at GCSE. And the idea of 3D coordinates, 3D finding a magnitude and a size and a length in 3D. It's not really just a bit of new notation, really. But despite that, because the questions are quite different, and the students do find them a little bit of a why. Not the first part of this question. I think most people do that. If we can kind of get around the dressing up of this question, I'm going to use kind of vector vocab of position vectors because I think it's helpful. We need to know this stuff after all. So if let's just say we're given a point A with position vector, let's just call our fixed position 0, the origin or whatever. Not going to make any attempt at all to make this, I can't because it's in 3 dimensions, to make this kind of some kind of accurate diagram. Obviously it's just a kind of visual representation, a sketch. So we've got 2 points A and B with position vectors. That A is that one and B is that one. I tend to prefer to write in column vectors, even if they've presented them to me with I, J's, K's. So I just find, in my experience, that less likely to make errors. Here's me writing all kind of funny numbers down, but you're less likely to make errors, and I find I'm less likely to make errors if I write as a column vector. So that's 3, 2, 0, making sure we put the 0 in the right place, because obviously 0 is missing from here because it doesn't need to be there when you write in IJK form, or it does when you're doing column vector form. And so that's OA, and OB is equal to 4, 2 minus 5. Okay, so those are the things, and it wants the length of AB basically. Now what I'm going to do, as I say, I think it's helpful. I'm going to dress this up, but it's basically 3D coordinates. You're finding the difference in these values, difference in this and this, and the difference in the kind of J values and the K values and the X, and squaring them, adding them and square rooting it. That's basically what we're doing. But so that's why most people had no problem with this. But I'm going to dress it up in the kind of normal vector kind of fancy stuff. So we've got OA, AB is equal to, using the triangle rule, OA minus OA plus OB. Let's get OA plus AB plus OB. There we go, have it. So it's basically minus of 3, 2, 0 plus 4, 2 minus 5. So that equals to 1, 0 minus 5. Okay, so that's that. As I said earlier, it's just a difference of coordinates. You don't need to write this all if you don't want to. I just think it's kind of useful in terms of kind of more, more difficult problems that might really require more reasoning with vectors. And so we're finding the magnitude of this. which is the square root of all of these components. So the square root of all the squares of these components added, 1 squared plus 0 squared plus -5 squared. Make sure we bracket that, which is the square root of 26. So that's the first part, very straightforward, and as I say, don't really need to even write in a fancy way. It's basically finding the difference of the i's, the difference of the j's, the difference of the k's components, squaring them, adding them, and square rooting them. 3D Pythagoras, basically, which you already could have at GCSE. Just new way of writing the same thing. Anyway, so that's the first part, straightforward. Second part caused some problems, so we'll do that now. So as I say, the second part it's a bit of problem solving. It's all about it's this. I've just moved this there. That length there is now a diameter of a circle. Okay, so let's just draw that. So we've got A and B. And remember, O is some point. This is in 3D. It could be tilted in any kind of way. It doesn't really matter. We've got points A and B, which are diameters of a circle. O is there. And we've got some other point, which is on this circle, OP, which they've given the position vector of. So they've given us all the form in P. So they've given us the position vector of P. So OP is equal to, and again I'm going to change that to columns because I prefer it, but careful where we put the 0 in the right place. So it's IJK, so P0 minus 3. Oh, by the way, don't mix the two notations. That's really bad. Makes you look like a bit of an idiot, really, if you do that. So don't do that. Columns or if you prefer IJK is fine, but don't mix the two. That's not clever. So OP is P0 minus 3. So what the question is to find the value of P. Now we're going to have to use some stuff that we already know. So this is, and I think a lot of people who did this just missed the fact it's that kind of stuff, you know, from circle geometry, that's right angles. But there is quite a bit of work to do if you think about it. We've already got the magnitude of AB from over here. We already know that AB, or AB squared if you like, is equal to 26. So we know that. But we need to get the magnitudes of the, let me put my A back in there. We need to know, in order to use Pythagoras, and in order to use the fact that this is a right angle, we need to know in terms of P or whatever what the position vector or the vectors AP are and what the vectors BP, or it doesn't matter what direction we go, but I'll go with that direction. So the vector AP, let's just get my colour right. The vector AP, we're going to have that so we can find the magnitude of it. And again, using the triangle law, it was a bit unfortunate the way I've tilted that. Let me put my 0 in another place. It's totally arbitrary where I put any of this. So using the triangle law, AP is equal to minus OA plus OP. Yeah, minus OA plus OP. So I'm going to write that down. Minus OA plus OP. Okay, and that equals to, well, we know OA, it's already given to us all over here or here. So we've got, that's minus 320 plus OP, which is this P minus P0 minus 3 above. So putting that into kind of putting those two bits together, you've got P minus 3 minus 2 and minus 3. And so AP. And of course we can do the same with kind of triangle arrangement with for BP. Let's change colours. So BP is equal to negative OB plus OP. So it's equal to negative, just the same as above, but with OB instead of OA. Okay, so that gives us OB is, again, it's written all the way up here, or in the question up here. That's equal to negative of 4, 2 minus 5 plus OP, which is exactly the same as what we've got above. So that gives us P minus 4 negative 2. You just notice I've missed a minus 3 there, so that's going to be equal to 5 minus 3, which is 2. So that's my BP. Okay, so now I'm ready to use my Pythagoras thing here. I already know, I know that this is a right angle here. Let's take that out now. We've already used that. We know that we've got a right angle here. So we know that we can apply Pythagoras' theorem, and we've got AB, P, we've got AB, we've got AP, we've got BP, and we can use the magnitudes of those and Pythagoras' theorem to basically work out the two values of P. So AB, the magnitude of AB P squared plus the magnitude of BP squared must be equal to the magnitude of AB squared. Okay, and that, so we got AP squared is these components, remember, squared, so that's P minus 3 squared plus negative 2 squared plus negative 3 squared, and then we've got BP squared, so that's this one here, that's P minus 4 squared plus negative 2 squared plus 2 squared equals to AB squared, which is 26. So that a little bit clearer, 26. Oop, there's gone a bit awry there, 26. So that's equal to 26. So that's going to give us what we need. Just a little bit of simple algebra, basic stuff here, but just be careful. P squared minus 6P plus 9 plus 4 plus 9 plus P squared minus 8P plus 16 plus 4 plus 4 equals 26. Rearranging that, you get 2P squared, and taking 26 over to the other side and everything, you get 2P squared minus 14P. And then we've got 9, that's 18, 22, 22, 32, 36, take away 26, 46, so let's do that again, that's 13, 19, 23, and you can see I've rushed, I knew the numbers didn't work out, that's 16, and then we've got 6 from 16, is this bit squared. So rearranging all that, that comes to 2P squared minus 14P plus 20 equals to 0. I'm going to half that. Plus 10 equals to 0. So we have, that factorises P minus 5, P minus 2 equals to 0. So P equals to 5 or P equals to 2. That's it. So that caused a bit of problem. I think most people didn't get as far as setting this up and using the fact that it's a right angle. But it boils down to, as I say, magnitude of a vector AI plus BJ plus CK. The magnitude of that, just 3D, is A squared plus B squared plus C squared. And then also the triangle rule that we kind of highlighted right at the start there. We have AB, if we want the vector AB, and we've applied that 3 times today, if we want the AB as a vector, you can just take away OA plus OB and then apply Pythagoras from there. Okay, so that's it. It wasn't really too difficult. It was one of the hardest of these problems, but despite that, as I say, some did find it a little bit challenging. Okay, that's it. Bye.